Yeah. Hello, everybody. My name's Mark, and I work for the Raspberry Pi Foundation. So could I just get a quick show of hands who's heard of the Raspberry Pi Foundation? Thank you. Who's heard of Raspberry Pi at all? Okay then. So what I'm going to do is I'm going to talk a little bit first off about the Raspberry Pi Foundation and some of the work we do, and I'm going to talk about one of our special projects, which is called the Astro Pi project. And I'll tell you a little bit about Astro Pi as well. Hello. Go get more people.
I'm getting them in.
More and more people.
Do you want to start when you're ready?
I've started.
Let's go.
I'm going.
It's 10 to everyone. No, sorry.
So,
Mark's gone.
I should have bought a... Could you do me a... Could you go grab me a Raspberry Pi?
Raspberry Pi.
From my... No, don't worry about it. Forget it. Doesn't matter. Doesn't matter. I should have bought one through. It's okay. So, those of you that don't know what the Raspberry Pi computer is, it's this little thing here. When you get a Raspberry Pi, it looks like a circuit board. It doesn't look like anything like what you think a computer is. Okay? And most people, when they look at it, they go, that's a computer. And this thing that's showing here is a computer. It's just a computer without all the extra little bits that you have. So there's no monitor or keyboard or mouse or disk drive or anything like that. Okay? So we call it a bare bones or a single board computer. And the nice thing about these computers is because they're really small and they're cheap to make, we can sell them for $35. Okay? We are a registered charity, so we make these computers, but we're actually a registered charity. And the way it works is that every time anyone goes and buys one of those computers, all the money comes back into the charity. It all comes back into the foundation. Here it is. Thank you very much. So this tiny little thing here costs $35. And we always price in dollars because we buy all our components in dollars. So we have to, that's the static price. It will always be $35. And every time anyone goes and buys one of these, that $35 comes to the foundation, and that allows us to do all our charity work, which I'll talk a little bit more in a moment. So we've just recently, just this summer, sold our 10 millionth Raspberry Pi, which makes it the most successful British computer ever made, okay? And it means that we've been able to do a huge amount of work in education. So our charity's mission, if you like, this is our mission statement, is to put the power of digital making into the hands of people all over the world. And when we say digital making, we're not talking about just programming. We're not talking about getting people to write lines and lines and lines of code, right? We like people to do what we call making, digital making. And what that is on the Raspberry Pi, you've got these row of pins here. So you've got about 40 pins, and with those, you can start controlling electronics. And if you want to come over and have a look at one of the little make sessions we're running next door, you can see some electronics being controlled by the Raspberry Pi. But that means we can use them to do simple things like make LEDs come on or off, or we can make them do really, really complicated things like drive huge robots, okay, that are completely autonomous and do what they want. So we're really, really enthused by getting everyone into digital making. And these are the reasons why we think it's important. Okay, we're living in a more digital world, so we think more people should understand about that. We want people to be able to solve problems. So a mate of mine recently took his Raspberry Pi, his burglar alarm system was completely destroyed. Okay, it wasn't working at all. Bit of electronics, Raspberry Pi, a bit of a code, and he had his own custom-made burglar alarm system. So it was a problem that he had and he was able to fix. And we want people to become better equipped for jobs for the future. And we do that in 3 ways. We accomplish our goals in 3 ways. One of them I'm going to talk about today. Okay, so we produce these little low-cost computers that everyone can use. All right, we run outreach and education. Okay, so our outreach event can be projects that we do, or we do teacher training and things like that. And we generate free resources as well. So on the Raspberry Pi website, there's lots and lots and lots of resources you can go and look at, projects you can have a go at, and you can learn how to do all this cool stuff. But one of the things we do is these outreach and education programs is we'll do things like we'll dream up an idea to do something. So one of them was a weather station project, and we dreamt up the idea that wouldn't it be nice if we could have Raspberry Pi powered weather stations in 1,000 schools all over the world, and we did it. Another thing we thought would be really cool was wouldn't it be good if we could send Raspberry Pis up into space? And at first, this was like a bit of a weird idea, you know, sending these computers up to space. But we talked to ESA, the European Space Agency, and with a few other people, and they said, yeah, this would be possible. We could do this. So I've got a video in a second, but the sound doesn't work for it, so I'm just going to skip over the little cartoony video that we've got. So what we did was we got together with the UK Space Agency and the European Space Agency. And the idea was not just to send a Raspberry Pi up into space. That wasn't the main aim of the project. The idea was that by having these Raspberry Pis up in space, we could get people to know a little bit more about the Raspberry Pi, and we could get kids to write code to run experiments that would then run on the International Space Station. So that's how the idea all started off. Okay, so we didn't just send a Raspberry Pi on its own. All right, because the Raspberry Pi on its own, as I said before, doesn't do very much. There's no keyboard, there's no monitor, there's nothing like that. So what we designed for it was this special hat. Okay, now this is the hat, this is the Raspberry Pi. HAT stands for hardware attached on top. Okay, so it's a bit of a laborious acronym that I think one of our engineers just made up for something cool. Okay, so we call this the Sense Hat. All right, and the Sense Hat will neatly fit on top of a Raspberry Pi like that. Okay. And you still get access to all the rest of the parts of the Raspberry Pi. So we've got my USB ports here and my Ethernet port there and my HDMI and my audio, and this is where my little hard disk slots in. But we put that Sense Hat on top, and that Sense Hat turns this into a very, very, very powerful device. Because all of a sudden I've got on here this 8x8 multicolored LED matrix. So I've got all these lights I can light up and blink and get to do stuff, and that can be a little bit like a monitor for me. I've got a little joystick here that I can control, okay, and send signals to the Raspberry Pi. But more than that, I've got on here a little sensor here that senses pressure, a little sensor here that senses humidity. And both of those also then sense temperature. And I've got a little sensor here that both does acceleration, so it'll detect when the Pi's doing that, when it's falling or when I suddenly start moving it. It's also got a gyroscope on there, so we can detect when the Pi's doing this. Okay, and it's got an accelerometer, a magnetometer on there as well, so we can detect any magnetic fields around it. So the Sense Hat turned our basic Raspberry Pi into a much more powerful device that could do a lot more things. Oh, no, I've got to go back. The other thing we did with them is we gave the Raspberry Pis a camera. Okay, and so we can attach onto these cameras, and we have two types of cameras. We have an IR camera, an infrared camera, and a visible light camera. None of the videos are going to work. So the idea was that with all these sensors and stuff on there, the Raspberry Pi could be used to run experiments in space. And then what we said was, we said to all the UK's children, we put this a competition out there, and we said, if you can write some code to run on your Raspberry Pi on the International Space Station, you write some code to do an experiment, we'll judge it, and the best ones we'll put onto the Raspberry Pis that are going up to the International Space Station, and you'll have your code running in space. Of course, when it came down to the nitty-gritty of trying to get the Raspberry Pis up to space, we started learning a lot about how things work and about how ESA and NASA works and about launch vehicles and this kind of stuff. So it wasn't quite as simple as just handing these over to Tim Peake and getting him to put them in his pocket and take them up with him. It didn't quite work like that. We needed to do some modifications. One of the first things we needed to do was we needed to make special flight units for the Raspberry Pis and the Sense Hats that were going on top of them. So we made these special flight units. Would anyone like to guess how much one of these cost to make? How much do you think it cost? £50. £50. Close. Should we go up a bit?
A couple of hundred.
A couple of hundred? £75. What do you think, Jimmy? You were going to say £75. So these cost £40,000 each to make. Okay. And it may sound silly, but these are specially designed, specially crafted aluminium cases. And I'll talk a little bit about all the tests that this had to go through and pass before ESA would allow it anywhere near a rocket. Okay. So first of all, we had to design these special cases. We had to make a little bit of modification to the boards. So these are the camera boards and these are the Sense Hats themselves. It might be a bit difficult to see on this, but they've got special paste that has to be pasted all around here on each of those boards. Okay, and we had to put this paste all over it because when you solder components, it doesn't always happen, but it can happen. You can get this stuff called tin whiskers, and you get these little bits of solder that sort of almost look like they're growing out of the device, and they can flake off. And why do you think that might be a problem on the International Space Station if you've got these little bits of metal floating around?
It might be dangerous.
It could be extremely dangerous. Why don't we have very much of up in space?
Maybe so like a rocket doesn't get hit.
Okay, good. Good, possibly.
We don't have very much oxygen.
There's not much oxygen. What else don't we have very much of in space, or we don't feel very much of in space when we're in orbit? Gravity. So any of these little bits of metal, they're not going to fall on the floor. They'd float around all over the place, and they could get into other electronics, and they could destroy electronic systems up there. So we had to do that to prevent that. So that was our first sort of test to pass. We then had a few other tests to pass. So they put the Raspberry Pi in this aluminium case, and they put it in a special room, and they switch on and they detect all the radiation that the Raspberry Pi is producing. And everything produces radiation. Okay, so you're all sitting there at the moment producing a little bit of radiation. It's infrared radiation, it's heat radiation. But electronic devices, they pump out all kinds of different electromagnetic waves, and they might affect the space station as well. We also had to put it on this thing. Who can guess what this does?
Makes like a hole.
No, it doesn't make a hole. It does something to the Raspberry Pi. What might it do?
Does it maybe activate some sort of electronic shield?
No. Moves back and forth, up and down, forwards and backwards, really, 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 really fast. Okay, so this thing shakes the Raspberry Pi as hard as it can, which is important because when we put these things in a rocket and send them up to space, they're going to be shaken really, really, really hard. We want to make sure that once they get up there, they're still going to be in the same condition as when we put them in the rocket. Okay, so that was another test we had to do. Next, 3 tests that it had to pass. Okay, this one's quite a complicated one. This one's called an off-gassing test. So we put it in this special sealed container, turn it on again, detect all the gases that come off it. This one's detecting its temperature changes and making sure that it doesn't get too hot or too cold when we turn it on. And this one, the most highly technical test of all, this man runs his gloves over it and makes sure that there's no bumpy bits or sharp bits on it, okay? Which may seem a bit silly, but again, if you're in space and we had sent up a device there with a sharp edge on it and Tim Peake cut himself on it, there's no hospitals up there or anything like that, okay? So we've got to make sure that everything that goes up there is as safe as possible. And so once all that was done, we then took it to a mock-up of the Soyuz capsule and the Soyuz cupola capsule on the ISS, and we put it on this special arm and we got it to sit there and check everything was all right. And then as we all did that, we ran this competition I talked about. So we had lots and lots of school children from all over the country get together with their teachers sometimes, or their scout group, or girl guide group, or whatever it was, and they started writing all kinds of code to use those sensors on the Raspberry Pi. These were the winners. So we had several winners. We had this group, okay, this young lady here with the help of a good friend of mine actually. They made a Minecraft simulation of the International Space Station. And while the Astro Pi was up in space, it's recording all that data, and as I said, it can detect whether it's moving, okay, left and right, up and down. It can detect whether it's tilted, all right. And so her Minecraft simulation of the International Space Station uses all the data from that launch, from when the Astro Pi was in space, and it makes a Minecraft ISS move around just like the real International Space Station was moving. So she was one. We had this group. They did a nice little thing where the LED matrix on it displayed different flags of the world, and every time the ISS went over a different country, okay, it would display the flag that it was of the country that it was over. This one's quite a complicated one. This kid used the camera and used the IR camera to take photos of the Earth, and he had a special algorithm in his code that basically did a bit of colour change, and it could detect whether there was chlorophyll, whether it was taking pictures of chlorophyll, so it was detecting the amount of plant life there is basically around, and I'll show you some results of his in a minute. This was probably the most technical one. These guys used the camera again, but they covered it up so it couldn't see any visible light, but what it could detect was any radiation that was hitting it, any dangerous radiation that was hitting it, this could detect, and they wrote a program to count that radiation. We've got this one was this This was titled Crew Detector. Okay, it was originally called the Smelly Astronaut. All right. Okay, but ESA didn't like that name. They thought it was a bit rude to the astronaut. So we had to call it the Crew Detector. And what it used was it used that humidity detector that was on the Astro Pi. So if you think about it, if you're an astronaut and you're working away around in space and you're sweating a lot while you're doing it because it's hard work, you're going to be producing that moisture and that going into the air, and that's going to increase the humidity. So this detected every time the humidity went up, it knew there was an astronaut in the room in that part of the ISS. So here's the guy that's responsible for most of it. Once all that code was written, you can't just dump that code on it and leave it. We had to get Tim Peake to run that code. So Tim Peake, as part of his astronaut training, had to be taught how to play all these games and programs that these children had written all over the UK, and he had to learn how to do it. So Dave, who's in charge of the Astro Pi project, he went over and he trained Tim Peake on how to use all that code. So the next thing to do was to try and get it up. This is the capsule that takes all the payloads from the rocket once it's launched from the rocket, either the Soyuz rockets or the rockets are launched from Cape Canaveral over to the ISS. So here's our stuff. Here's our Astro Pis being all bagged up and ready to get onto the rocket. You can see they were going with a couple of other things here. So there's a couple of crew-specific meals that are going up as well, and obviously more importantly, and then I would normally show you the launch from Cape Canaveral now, but I can't because the videos aren't working. So they went over to Cape Canaveral and they're all set up in their nice little viewing booth ready to watch it, and then there was a huge water leak at Cape Canaveral, so they all had to evacuate the area, and the guys ended up standing that. Here's a view from the ISS. So this is capsule that's going up, Cygnus capsule that's going up with the Astro Pis in it. And then on December 2015, it docked with the International Space Station. So our Astro Pis were there at the International Space Station, but they weren't taken out yet. The next thing that had to happen was this guy had to go up. So our Astro Pis were originally due to go up with Tim Peake, but because there's some electrical problems on the International Space Station before Tim Peake went up, they had to send some extra kit up to fix those electrical problems, which means the Astro Pis didn't get to go up at the same time as Tim Peake. Later, but once Tim Peake was up there, we had our Astro Pis taken out of the launch vehicle and then they were put into the International Space Station. So here's the Astro Pi with the visible camera on it, and that's sat in the cupola. And here's another one, and this one's looking out of the cupola window. This is the one with the infrared camera on it, looking out and looking at Earth constantly. Has a slight view, slightly different away. And just to prove absolutely 100% that they are up there in him. I mentioned earlier that we had that Crew Detector program running. So this was the Crew Detector program running. This was more or less a planned shot, okay? So Tim Peake, when he started taking photos, whenever he detected an astronaut was in there with him. This is the result of the one that I said was doing, looking just about see when you put this false colour on it, you can see what chlorophyll is, and you can see there's actually quite a lot of algal blooms here in the Bristol Sea. This is a space station that was modelled in Minecraft. So, our Astro Pis are still sitting up there. They're still on the International Space Station. Now, Tim Peake's come back down, but they're still there. But the program's experiments have been run. They're done. But what's happening is this guy, Thomas Pesquet, is going up to the International Space Station soon. He's not already up there, playing around with data. And all I can say is I'm pretty sure that there's going to be an announcement next week. Okay, there'll be an announcement next week regarding future Astro Pi projects. So check out our website, keep an eye out on our website, and you'll be able to see maybe how you could get involved. You could bully your teachers at school to get help. Okay.
You got spare time to answer questions?